clinicians, physicians, scientists at literally the top of their fields from all over the country and all over the world. We coordinated for all of them to be here today to speak to all of you. So we are all privileged to be here. I'm going to introduce each one of our speakers soon, but because I'm not at their level, I'm just going to get myself out of the way. I'm originally from New Jersey. Anybody from New Jersey here? All right. Don't boo us, okay? We're good people. I'm an internal medicine physician. I'm originally from New Jersey, and I came to the villages to join the Aviv Clinics. Partly, their research in stroke is what led me to get wind of what they do. But eventually, you're going to hear from a lot of physicians that will talk about the aging field. And the future of aging and longevity is what we do at the Aviv Clinics. And each one of these presenters today will go into detail of what you can do, because you all have a choice on how you age, even today. So please listen. Keep your questions to the very end. We are actually going to go through a Q&A session with the whole panel at the end. So just sit tight, absorb, and at the end we'll go through some questions. So we'll give the last few people a chance to come in, but in the meantime, let me start introducing who we have. So we got me out of the way, but I want to mention one of the physicians who unfortunately isn't going to be here today, Dr. Michael Roizen. He is the emeritus professor at the Cleveland Clinics and the author of the New York Times bestseller list, The Great Age Reboot. So unfortunately, he can't be here today, but a lot of his information will be presented through the other presenters. Next, we have Dr. Nir Barzilai. He's the director of the Institute of Aging Research at the Albert Einstein College of Medicine. He's also the director of the Paul Glenn Center for Biology of Human Aging Research and the National Institute of Health at the nation's Salk Center for Excellence in the Basic Biology of Aging. We also have Dr. Eric Verdeen. He's the president and CEO of the Buck Institute for Aging on Research. This institute is world-renowned for all the greatest scientists, clinicians, physicians, researchers working together just on the aging process. And then we have Dr. Joe Maroon. Who here is a Pittsburgh Steelers fan? All right, sorry, Joe. Not too many fans here, but it's okay. He is the head neurosurgeon for the Pittsburgh Steelers, as well as the vice chairman in Department of Neurosurgery at the University of Pittsburgh. And then we also have Dr. Amir Hadani, who is the head researcher for the Aviv Clinics and the chief medical officer of all the international operations for the Aviv Clinics, and works very closely with Dr. Shai Efrati, who also couldn't be here today. Are you all ready to learn? No, you're not ready. Are you ready to learn? All right, there we go. So first, I want to welcome Dr. Nir Barzilai.
Thank you. It's so exciting. First of all, it's so exciting to see the enthusiasm here. It never happens with students that I say, "Are you here?" and they are all screaming, you know? So thank you for that. But also, I'm excited just to be here because we're here because there's a very interesting technology that's working there that we think has a huge impact on aging. And I feel like I'm the warming act eventually to Amir, who will tell you about it. But let me bring you to our world with the following example. It's actually a story that I heard here. There's an insurance village company, something like that. Anyhow, a 100-year-old guy walks to the life insurance company and wants life insurance. And the clerk says, "We don't give life insurance to 100 years old." And he said, that's not true because my mother is insured here. "How old is your mother?" "She's 120. She's okay?" "Yeah," he said, "she's okay." So the clerk thinks better. They go to the boss and they say, "Wow, that's a good marketing plot." They go to the elderly and say, "You know what? Come on Tuesday. We'll have everything ready. We'll be happy to give you life insurance." And the guy says, "I'm sorry, I'm busy Tuesday." They said, "What do you have Tuesday?" He said, "Tuesday, my grandfather is getting married." Said, "How old is your grandfather?" 150. 150, he wants to get married. He said, "No, he doesn't want to, but his parents puts lots of pressure on him." Now, you think it's a joke, and you'll see it's not a joke for me. It's really where I am. So, look, We have 100,000 years of human evolution. Not that long, but it's about 100,000 years. And during all those years, life expectancy was between 20 and 30, okay? It's only in the last 100, 150 years, that's why it looks straight line, because on the time scale, it's very little. Life expectancy went up, and it's 80 around the world. It's dropping in the United States. That's a different, it's 76 now. That's a different issue. But, so this is a huge achievement, right? We tripled our life expectancy, but it came with a terrible price. After the age of 60, we start to accumulate age-related diseases that were not there before. Okay, in human evolution, there was no Alzheimer's, cancer, diabetes, cardiovascular disease. Okay, it wasn't there. And now, after the age of 60, we get one disease, and it might be terrible, and a treatment, and then a second disease, a third disease. Eventually, we have a bad quality of life. What happened that we got to where we are? It was a lot about prevention, okay? Harness agriculture, clean the water, build sewers, vaccination, okay? Yes, there's also other things that help, invention of antibiotics and surgery, okay? But a lot of it was prevention. And that means that while thinking of prevention, and I think, by the way, prevention is part of what this technology you're going to hear about is all about. It's not treating a disease, it's preventing a disease. So it's all about prevention that we are thinking that we have to create a new history. And we're in the middle of creating this history. So you know that aging is a biology because you know who's old and who's young, okay? What people didn't realize until recently is that aging, this biology that you can see on, just in recognition, this biology in our cells is what drives those diseases. Okay, those diseases are driven by the biology of aging. It's not that the disease makes you old. It's that the aging gives you a disease. So you can be born with genetics for Alzheimer's, and you're not going to be demented when you're born or when you're 10 or 50 or, it takes 70 years for you to develop that. It happens only with the help of the biology of aging. I have grants to prevent the biology of aging as an Alzheimer grant to show that we can prevent Alzheimer by delaying the aging process. And yes, this is the great promise around the world in labs, and you'll hear Eric and in my institute. We've shown over and over again that we can target this aging, this biology, that we can prevent or delay variety of age-related disease, and in some instances we can stop and reverse aging. It's never too late. The reason we are successful is that we found what we call those hallmarks of aging. And I'm not going to tell you about those hallmarks of aging, but each one of them means that something goes wrong with aging, and when you fix it, what you get is an improvement on health span, most important, and lifespan. If you want to look at it, we are interested in health span. We want to make you healthy. The side effect, you live longer. Sorry, okay? Maybe you cannot afford it, but it's about health span. But we can improve the health span and lifespan of variety of animals by targeting those hallmarks. And not only that, you see that those hallmarks are related to each other, which really means that you can target one and get effect on the others. Okay, you don't have to do it all together, and that's very important to know. Now, what we want, if you think about it, is to take you guys, okay, to a study and give half of you a drug and half of you a placebo. And we want to see what happened in 5 years. And we want to see that those with the drug die less than those with the placebo, right? That would be what we're aiming at. And the question, is there a drug like that? Yeah, there is a drug like that. It's called metformin. Anybody here takes metformin? Yeah, I see about 10, maybe more percent. Lucky guys. So metformin is a drug that's given to diabetic patients. But metformin was actually, it's an extract of the French lilac, so it's kind of nutraceutical but modulated, so you cannot get it over the counter. But it was used to prevent flu and malaria, and then it was discovered that it lowers glucose in diabetic patients, and that's where it's been used. But it's been used extensively and chronically, so there are billions and billions of years of use since metformin has been on, and we know a lot about it. So for example, I'll show you this study, and this study took, I'm too fast on the trigger here. This study took about 180,000 people in pharmacies in the UK, and the doctors in the UK decided which drug they're giving their diabetic patients, either a drug that's called sulfonylurea or metformin. And you can see here that those on metformin have died less in 5 years, okay? Now, it's not because they had better glucose control. In fact, they had worse glucose control. And it's not because of other things. In fact, they were more obese than the people with sulfonylurea. So it's not one of those things. Something else happened with metformin that prevented their mortality. But I'm showing you this slide for another reason. They had control groups. In other words, people who were treated in the same pharmacies by the same doctors, but they did not have diabetes. And those people who did not have diabetes had more mortality than people with diabetes and metformin. Okay, so metformin was, even though you had diabetes, metformin protected you from mortality better than others. And what we are doing is we are pushing now a study with the FDA to ask if we give, you know, the 90% of you that are not diabetic here, that are not on metformin, if you give them metformin, would it prevent mortality? But more important, it's not about mortality, it's about health span. And we already know about metformin, that people who take it and are not diabetic, it will prevent diabetes. People who are not diabetic and have cognitive decline, it prevents the deterioration in cognitive decline. People on metformin have 30% less cancers, all cancers. People on metformin have less cardiovascular disease and less mortality. By the way, there are better studies that show that there's less mortality. Why, you're asking why can't we start metformin? Because the FDA doesn't approve prevention yet, okay, as an index. And if FDA doesn't approve, your healthcare provider don't have to provide you with metformin. By the way, metformin is the cheapest drug in the formulary, okay? So that's not going to be an issue, but we need to show the FDA. And not only that, if we show the FDA, then pharmaceuticals will come in and develop better drugs, okay? Or you'll see a better technology that exists here in order to improve your health span. So this study will take 3,000 people, and in a placebo control will show that it prevents all those outcomes, prevents or delays significantly all those outcomes, and then we can have FDA approval. Now, is metformin the only drug? I think Eric will suggest that it's not the only drug. There are other things that we can do even before taking any drug. I'm just giving you an example. But the point I want to make is our lifespan as humans is 115 years. It's a statistical thing, okay? There's somebody who lived 120, probably more than one person who lived 122 years, okay? About 115 years. But we die before the age of 80 on average. So there are 35 years to realize right now. So how can we make an advance? And one of the things that I'm doing is related to the story I told you initially. And what I have is I have a group of 750 centenarians, those are 100 years old, and their families. And this is an example of a family. Those are 4 siblings that were born in New York City between 1910 and 1920. And the important thing about them is all of them got to be above the age of 102, okay? And by the way, Helen, who's the big sister that died at 110. I met her in New York apartment when she was 100 years old. She opened the door and she smokes. and I say, Helen, nobody told you to stop smoking? And she said, you know, all the 4 physicians that told me to stop smoking, they died. So one lesson can be if you smoke for 85 years, you live long life, okay? But really, the point here is that a lot of them, 60% of men, 30% of women were smoking. More than 50% were overweight or obese, exercising less than 50%. Those guys, what they do, they have longevity genes that slows their aging, which even with the environment, they couldn't care less, okay? I told you about this genetic for Alzheimer. We have 2 men that should have been demented at 70 and dead at 80, and they're 100 years old and not demented, okay? So if you slow aging, you can overcome lots of things. Now, this is the important thing. You ask, just a minute, did they get disease when everybody got disease? And now they just live sick longer? And the answer is no. What you see here is that everybody is healthy here. That's the one. Everybody's healthy. And our controls are starting to get diseases after the age of 60. And at age 80, only 10% don't have disease. But you see that the centenarians get diseases 20, 30 years later. And even after the age of 100, 30% of them don't have any disease, don't take any drug, okay? So this is an example, okay? It's possible, okay? It's possible to do that. They're doing that maybe with genetic help, but they're doing that. And an important fact that's very important, and we can pick it later, is they have compression of morbidity. They're sick very little time at the end of their lives. So they live healthy, and die, and that has a huge economical implication. If we can do that, we're contributing to the economy immensely, and I'm talking about something like $300 trillion over 10 years. It's a huge longevity dividend, and that's what we're trying to do. We're now trying to recruit more centenarians in initiative, 10,000 more centenarians to find all the longevity genes, because we already developed gerotherapeutics. We developed drugs that target aging based on the genetic data that we have. And so I think I'll stop here. Just to tell you, because you'll hear another round of maybe a little bit overlapping things, but just to tell you, again, the main points will be done with Amir, because we are here hunting for, we're talking about drugs, but is there other technology that has such a big impact that can prevent aging or age-related disease or some other conditions? And we were excited to learn the potential here. In fact, I'll tell you that I have in my institute a hyperbaric oxygen chamber, because I'm trying to figure out the biology on those, on mice and rats. So I'm just looking forward this new expansion, and you're lucky to live in an area that has an access to that. So, okay, thank you very much.
Thank you, Dr. Barzilay. Do not start smoking if you don't smoke, okay? I'm watching you guys. Okay? Next, please welcome Dr. Eric Verdeen.
Good morning. Let me start by first congratulating all of you for being here, because being here is step one, or maybe for you it's step 20, but in being conscious about your health. And really, one of the messages I want you to leave my presentation with is this, the idea that your longevity, your health span, how you will spend the late years of your life is on you, it's on us. And so let's just get started. I've arranged my presentation in a few key no slides? All right. Thank you. Okay. In 4 breakthrough that in some way will be overlapping with what Nir has just told you, but I think there's virtue in repetition. So hopefully by the time you leave this presentation this morning, you'll be on top of what this field is all about. Breakthrough number 1, aging is a major risk factor for disease. In fact, it's the biggest risk factor for a whole series of diseases that are outlined here. Atherosclerosis, heart attack, stroke, glaucoma, macular degeneration, cancer, many forms of cancer. Not all cancers are age-related. Osteoarthritis, osteoporosis, hip fracture, hearing loss, sarcopenia, Alzheimer's, Parkinson's, type 2 diabetes. That sounds like a lot of fun, doesn't it? Unfortunately, it is the reality of what it means to get old today. And many of these diseases, by the way, did not exist 100 years ago. People were dying, as Nir said, from infectious diseases. And over the last 100 years, we've essentially eliminated almost completely most infectious diseases as a cause of death. But this has uncovered a whole series of new pathologies that you're all familiar with, because it turns out if you're above 65 years old, 70% chance that you carry at least one of these conditions. And by the time you're 70, most people carry 2 of these conditions. So this is why, if I ask this whole room just one quick question, who wants to live to 150? Almost no one. You, okay, good. Now, let me just rephrase the question. Who wants to live to 150 in the same physical condition, mental condition, surrounded by your families? Okay, right. So that really is the whole equation. We associate aging with disease for a very simple reason. Aging is associated with disease. What I'm hoping to convince you is that it doesn't have to be this way. Now, this is what most of us will go through. Average life expectancy in the US, about 80. Actually, it's gone down now because of COVID to 76. But this is not the important number. Healthy living until 65, and by then it starts degrading. Now, we have a vision that this doesn't have to be this way, and you might be wondering, well, what makes you think that this is actually possible? And Nir just hinted to this. When we looked at the centenarians, they not only live to 100, but they have what we call a compression of morbidity. Look at the red bar there. It's only 5 years, about 5% of their lives. So not only do centenarians live longer, but they live better. Now, the true delta between us and the centenarian is 65 to 95. That's 30 years of healthy living. I mean, to me, that's amazing. So some people in our field will tell you we're going to live to 150 or 300 or 800. Don't pay attention to this noise. This is not what the serious people in the field are working on. We're working on the delta between 65 and 95. And just today, there is evidence, strong evidence, that lifestyle factors can give you an extra 12 to 14 years of healthy life. That's already what we can do today, which is by itself already important. So, breakthrough number 2, you can control the way you age and the rate at which you're aging. Now, that sounds a little bit worrisome or sort of disturbing, because most people assume my parents died young and we don't have good genes in our family and so on. Nir pointed to the fact that centenarians, the centenarians today tend to have a very strong genetic background that protects them. So many of them actually have poor lifestyle, and despite this, they still live very old. But for most of us, it turns out that the ratio of genetics versus lifestyle is completely different, and I'll show you. So this is a study that emerged 2 years ago that I think has made quite a bit of noise. It's still a little bit controversial, but it still is an important study. What it shows is the relative role of genetics, your DNA, what you've inherited from your parents, versus lifestyle. And when I say lifestyle, it starts in the womb, all the way throughout your life. The air you breathe, the food you eat, your level of education, all of this. It turns out that 93% of your life expectancy, your health span and your lifespan, is determined by non-genetic factors. And that, to me, when I saw that data, I thought, this is incredibly important, because it means it's on us. We can't blame your parents, you can't blame anybody else. It's really how you live that will determine how well you will age. And we all know, among our friends and family, some people who seem to be doing everything right and they look younger, and that difference will continue to grow. So now the question is, what does that mean, non-genetic? What can I do today? And this is what I call the 5 pillars of aging. And you have heard this before in some way. All of us have heard it. But I will go through it anyway, because I think the field is working on all of these interventions. They're part of a whole package. The way I think about every one of those is money in the bank. Think about when you're investing for your retirement. People told you start early. Same thing for your health. So think about your health account. Everything you put into it will eventually pay back. So people say, I don't like to exercise. Well, you don't have to exercise every day, but every day you exercise, you're putting money in the bank. And the same goes for every one of these interventions. So when you think about your own health, a lot of people have this idea, they have to do everything perfectly. Every step that you take that increases your health will increase your health. And there's compounding interest for those of you who are in the financial world. So the earlier you start, the better off. But it's never too late to start also. All of our studies in animal models show that many anti-aging interventions still have an effect no matter how old you are. So let's go through them. The first one you probably recognize, that's nutrition. A lot of discussion about what is the optimal form of nutrition. Lots of discussion on this diet versus this diet, keto, paleo, and so on. I don't think this is the important question. The most important question is how much you eat, which most of us actually eat too much. How much you eat, and fasting is also emerging as a therapeutic modality that really has profound anti-aging effect. And well, unfortunately, we only have 10 to 15 minutes for this presentation, so I won't be able to go through all of this, but hopefully during the panel we'll be able to go back and ask specific questions. So nutrition. Physical activity is, I think, the granddaddy of all of them. Now, I'll just say one thing about physical activity. A lot of people say, well, I don't like to sweat. I just don't like to go to the gym. I've never done any sports. Walking. Who is walking every day here in this room? Good. All right. Well, you all look like an incredibly vibrant group of people. You're here, so you're already doing the first thing. But I would hope that everyone who's going to leave this room will commit to, at least for 1 week, to walk 20 to 30 minutes a day. That's the best thing you can do for your health. And in my opinion, there's no reason why anyone can do this unless you have some form of physical problems that prevent you from doing it. So walking every day, 20 to 30 minutes, is an amazing anti-aging medicine. And the numbers support this. Number 3, sleep. Really the granddaddy of them all. Because your sleep allows your brain to rest, and your brain is the one that makes all of the decisions that you're going to make every day. I don't know about you, but if I have one bad night of sleep, the next morning I'm craving all of the bad things, my diet goes off, I don't feel like working out, and so on. So your sleep is really, think about it as sort of resting the decision maker who's going to allow you to keep and stick with all your resolutions. So most of us, by the way, at least most of the American population is sleep deprived because of light, and now because of screens. And it's only getting worse. So resting every day. Most of us actually, by the way, need 8 hours of sleep. Now that seems like crazy because most people get about 6. So think about this. How can you optimize your sleep? Really important. Number 4 is actually one of my favorite. It's social connection. When people have studied what are the biggest predictors of a long, healthy lifespan, is your social connection. And the fact that you're here, you live in this amazing community, is a reflection of the fact you've taken an important step. Having friends, and it can be your spouse, it can be a friend, it can be a child, it can be it's someone that you care for, but having these strong social connection, and the larger number you have, the better off you will be. And I always say that when you are thinking about your lifestyle interventions, For example, I know some people who have extreme diets. No gluten, vegan, this and that. Nobody invites them to dinner. Think about the consequences. That diet might be a little more healthy than having meat once a week, but if it kills or prevents you from enjoying your social connection, think about it twice. So that's another important one. Finally is drugs. And I know a lot of people want to have a magic pill that we're going to be popping up and it's going to make you live forever. That's not what this field is all about, because I believe that these drugs will come on top of your foundation. First, the drugs are not available today. We've heard about metformin. It is available today, and many people are taking it in the hope that it will work, but we don't know if it's going to work for sure. And every drug has a side effects and a consequence. And my philosophy is that build your foundation in the hope that the drugs will come in the next 10 to 15 years. I predict there will be a drug in the market that will delay aging. But they're not there today. And so think about all the rest. Build that foundation. And again, think about it as money in the bank. Everything you do along these lines will help you to live healthy longer. Breakthrough number 3, I want to expand a little bit on these interventions that are pointing in the future. And in some way, you are incredibly lucky to have the Aviv Clinic right here near, and our colleagues have been visiting for the last 2 days, trying to see, how do they plan to use this hyperbaric oxygen therapy and other interventions to increase and maximize your lifespan. Having this in this area is actually really important. So I'm going to focus a little bit on what we have learned of how we can change the rate of aging. So we've identified a number of dials. Think about a cell has, we know, about 25,000 genes. Each gene encodes a protein. Some of these proteins, when tinkered with, will change the rate of aging. And I want to give you an example first of an experiment that was done actually quite a while ago, 80 years ago, in which you start with 100 mice on top. This has been done in mice, in rats, and other model systems. You can see you follow them over time, and look at the orange line, the non-CR. It goes down by 36 months. Most of these mice are dead. So that defines a maximum lifespan of a mouse, about 3 years. Now, you take these animals and you actually restrict the amount of calorie that they're eating by 25%. Look what happened to them. They now live about 10 to 15%. You restrict the calorie input even more, 55, 65%. You can't go further because they become malnourished. And you can see these mice actually living longer and longer, up to 50% longer. That's amazing, because and these mice are not disabled, they actually are healthier. So think about all of this life that was wasted by eating too much. I mean, the same goes to humans. And I suspect because the pathways that are regulating these effects are conserved in humans. I'm going to show you this in 1 second. Now, this data has generated a lot of interest, because it means really aging is something, it's plastic. We can modulate it, we can regulate it. Here with a simple intervention, just cutting down the amount of food that these animals are eating. Now, so people have been busy in the field of aging research trying to identify what are the pathways, how does this work? So you see calorie restriction in red, long life in green. What we've been doing, we as the whole field, my lab has been actively working in this area as well, is using these animal model systems in which calorie restriction works to try to find what are the pathways, what are the tools, what are the molecules that mediate these effects. And one of the amazing things that has emerged is the fact that it's the same mechanism in every one of these organisms. And I want to point my finger and your eyes to TOR, target of rapamycin. This is a molecule that is present in every organism, in every one of your tissues. And rapamycin is a drug that, when given to every one of these organisms, increases lifespan. It's what we call a calorie restriction mimetic. So it has the same effect as if you were on calorie restriction. So imagine now this drug coming into the clinic. And the good news is it's already in the clinic. It is being used in people who have received a kidney transplant at high dose. It's actually called Rapamune. And there is data that even these people who have had a kidney transplant actually seems to be living longer because of the rapamycin. So obviously, this is another drug in addition to metformin. Metformin is also a calorie restriction mimetic that we think in the future will come into the clinic. So last point, because I've just been given the 1-minute signal, is that we think that this will lead to a reinvention of medicine. And this is what the field is really working on. So think about how medicine is organized today in silos. So you might be a healthy 65-year-old, and you're doing well, and all of a sudden you have a heart attack, inaugural heart attack. First, how could you be actually considering yourself healthy and have a heart attack, which in close to 50% of the cases will actually take your life? Really, there's something not working in this system. So let's say medicine has actually been incredibly good at curing heart disease now, and you survive your heart attack, you go away from the cardiologist, you go back to your life. Remember, the time keeps ticking, and now 5 years later, God forbid, you develop a cancer. You go see, and so this is now entering the new silo. You move away from the cardiologist, and you go see a cancer doctor who's going to give you chemotherapy, surgery, radiation therapy, and so on. And again, medicine has been making enormous progress in terms of curing cancers, immunotherapy, and all this. You've heard about all these new developments. It's true. We're much better at curing cancer. So your cancer gets cured, you get close to 80, and remember my curve, all of these diseases keep going up. You reach 80 years old, and by that time, you have 25% chance of developing Alzheimer's disease. Then you are put in the hands of a neurologist. Again, the point I'm trying to make is medicine is highly siloed. It treats all of these diseases as if they were independent occurrence. They're not independent occurrence. They're all a reflection of the same factor. The biggest risk factor for all of these diseases is aging. Okay? And you all know that aging leads to these diseases. The question is why? What are the mechanisms? Okay? This is really what the field is trying to understand. So what we think this will lead to is a reinvention of medicine. Everybody talks about healthcare. We don't have healthcare. We have sick care. We treat care of people who are sick. It's organ-based, or it's, again, like the silos. It's reactive. We wait for people to be sick, and then we manage diseases, and it's universal. Pretty much everybody gets almost the same treatment. And so the vision we have is really moving to a true preventative healthcare model. By the way, we spend 50% of all of our healthcare dollars in the last year of life. 50%. I think we should really spend a lot more earlier to prevent people from getting sick at the first place. And I think that's a decision that we have to make as a society. So we want to move to a system-based type of healthcare, much more proactive, starting at 30. And this is the time when you have to start thinking about all these interventions, preventative and personalized. Last word, this is the incredible group of people that I have the privilege of leading at the Buck Institute for Research on Aging in Northern California. This is a beautiful place. If you ever are in the area, let me know. Come and visit. This is my address. Thank you.
Thank you, Dr. Verdine. I noticed as soon as the calorie restriction slide came up, nobody went up for seconds. So very good. You're listening. Good. Next, I want to bring up Dr. Joe Maroon, and please welcome him to the stage.
Thank you. Thank you, Mo. Thank you very much. Thank you very much. Mo, it's a great pleasure to share my experiences with you. You've just heard three of the most preeminent, knowledgeable scientists in the world in terms of, and you will hear Dr. Hadani in just a minute. I'm basically a clinician. I've been at the University of Pittsburgh for the last 45 years or so, and I've taken care of patients with traumatic brain injuries, brain tumors, strokes, Alzheimer's disease, and various things like that. And what I'm going to share with you today is some of my actually personal observations, and also interest in my own career, my own life. I'm at an age with many of you here in this audience. I'm an octogenarian. I don't like to say the word 80, but I'm here, and much of my career, as I said, has been spent with the Pittsburgh Steelers. I was the first appointed neurosurgeon in the NFL 100 years ago, it seems, with Mr. Dan Rooney, and I've taken care of many patients with concussions. I'm going to ask you a rhetorical question. What is the most common cause of concussions? Falls. And in this age group, in my age group, I can't tell you the number of subdural hematomas and blood clots and trauma that I've seen because of falls. So I urge you always to be incredibly careful in that regard in everything you do, your rugs, your banisters, and everything else. But early on in my career, we started a clinic at the University of Pittsburgh, the concussion clinic, and we have 7 neuropsychologists who do nothing but evaluate patients with concussions, 8,000 new patients a year, and the treatment thereof. And there's a condition called the post-concussion syndrome, where having had a concussion, one subsequently can be left with debilitating memory loss, impaired emotional disturbances, and headaches. And what do you do with that? Well, most of them get better on their own or with the therapy that we use in a clinic. But there was a small cohort of patients that came to me who had intractable headaches, intractable memory loss, and emotional disturbances. And I, several years ago, started sending these to an individual who had a hyperbaric oxygen chamber in Pittsburgh, and the mothers and fathers would come back and say, "You've given me my son or daughter back." And then I read this paper by Dr. Hedani, who you're going to hear in just a minute, about the effects of hyperbaric oxygen therapy on post-concussion, post-traumatic injuries. And this is an example of a young lady who came here to the Aviv Clinic not too long ago, a 15-year-old girl, all-American soccer player, incredible career, straight-A student, had a concussion. 5 months later, after seeing 10 practitioners, a neurologist, psychiatrist, being put on psychotropic drugs, antidepressants, mood elevators, nothing worked. And she was referred to me and subsequently here to the clinic for the treatment that I will describe on myself. And after the treatment, she's now competing back in national class soccer, has regained her ability in school at scholastics and academics, and is doing extremely well. I mean, it's an anecdotal story, but the data that you're going to hear from Dr. Hedani substantiates on a scientific basis what we're doing. And this is a recent paper, 2022, just a month or two ago, on the use of this in kids, a randomized control study for post-concussion syndrome. So that it's something, again, to keep in mind that you're knowledgeable about now. My mother died of a stroke at age 76, and I've been very aware, conscious myself. Genetically, I'm predisposed to that, I'm sure, in terms of atherosclerosis. So I'm very aware of what can be done to prevent it, and also, if one has a stroke, what do you do to treat it? What's available? Most people say it's time. Give it time, and you'll get better. Well, there's also data that you're going to hear from Dr. Hedani on the therapeutic benefits of hyperbaric oxygen therapy in patients with stroke, up to several years post-stroke. And again, a data point that you want to keep in mind. As a neurosurgeon, I've taken care of many patients with spinal cord injuries, broken necks, traumatic car accidents, falling off of bikes, innumerable types of injuries that can occur. With a traumatic spinal injury, there's an initial hit that damages the axons and the neurons. And then there's a secondary inflammatory response that continues after the injury that leads to inflammatory processes, swelling, and further destruction of the myelin and of the neurons in the spinal cord that prevents recovery. This is a patient that I'm going to show you a movie of, an NFL player from the Pittsburgh Steelers 3 years ago, who an All-American from Ohio State, who made a tackle that you'll see. And on the upper left, you see the vertebrae, and the white on that is a small hematoma, and the second is a post-op MRI, or post 2 days MRI with an enlarged white hematoma compressing the spinal cord. And we subsequently operated and put this instrumentation in. But in addition, we used hyperbaric oxygen therapy for this particular patient. And this is a paper that showed that it does improve spinal cord oxygen tension. It's an anti-inflammatory. It enhances stem cell production, reduces swelling, and increases new blood vessel formation by stimulating a growth factor called vascular endothelial growth factor. So that we then use this and place the physician in a hyperbaric chamber, and subsequently he's made a very good recovery. This is the injury.
He has been supplanted as their lead back by the rookie Joe Mixon, who's looking on from the sideline right now.
Hey, let's go L90.
This is at Cincinnati. The Steelers playing
On 2nd and 5, plenty of time for Dalton.
number 50. You see he immediately grabs his back, rolls over, has no function in his lower extremity, grabs his head, and says, you know, he knew exactly what happened to him. He knew immediately that he was paralyzed.
Shallow cross, you're going to see Shazier, the middle
And
linebacker.
so again, in slow motion, bang, and that was it.
Down, and that's never a good thing.
So, so basically, he injured his spinal cord, and I showed you the x-rays and the blood clot, and he subsequently made a very dramatic recovery, and we actually published the paper in the Journal of Neurosurgery on the management of spinal cord injuries in athletes, and this is one of my favorite pictures. This is he on your right, the bald fellow, helping to carry off Mason Rudolph, who had a concussion against Cleveland, helping him off the field, which was just the most incredible picture of ironies that I can imagine. A man who was paralyzed helping this brain-injured athlete walk from the field. So, Dr. Verdun, earlier today, we were talking about the importance of observations in terms of science and neuroscience. William Sweet was a professor of neurosurgery at Harvard, whom I knew several years ago. He said, "I believe we become excessively imbued with the conviction that a randomized, statistically significant series is necessary for firm conclusions. We need to establish faith and the capacity of the biologist to reach a valid, novel conception on the basis of a single set of facts. There's a staggering difference between 0 and 1 when the 1 is a good idea." I read this many years ago, and this really resonated with me, the difference between 0 and 1. Each of you is 1. And so what does this mean? So having the experience treating patients with concussion, stroke, and other problems over the years, I had a period of time, a year and a half ago, where I said, I'm going to try hyperbaric oxygen myself. And I came down to Aviv, I rented a home, and subsequently we've purchased a home here. So I'm stuck in a way. But we purchased a home afterwards, and I did 63 months, 5 days a week, and had the hyperbaric oxygen therapy. But beforehand, I didn't want to finish up and say, gee, I feel good. Okay, so what? So I wanted to approach this as the difference between 0 and 1. So I wanted to measure every parameter I possibly could before and after. So Roger Miller, who's a brilliant neuropsychologist who works full-time here at the Aviv Clinic, took 2 hours of testing my memory, my orientation, my ability to process, my brain speed, and quite frankly, it's a little humbling. When you think you know something, you think your brain's working pretty well, when you're put to the test, you see little, kind of like Swiss cheese. And then I also had sophisticated MRIs, SPECT scans, imaging of my brain, and then did a cardiopulmonary test, a treadmill test, and measured my respiratory function, balance, flexibility, and telomeres, and also my proteomics. And in quick summary, there was an improvement in all of the things you see here: recall, executive function, attention. And my brain scans, which are very objective, I can't fake this. I can't say, gee, my brain is flowing better. We have objective pictures, pre and post, and the different colors on the bottom slide is post, showing increased perfusion and blood flow through the brain. And this is a SPECT scan, and the top is pre, middle is post, and the delta, the difference between the two in terms of blood flow to various parts of my brain, are highlighted in the bottom picture. And that correlated with the areas of functional activity that were enhanced pre and post-op. So there's clinical neuroradiological confirmation of what happened in my brain blood flow-wise and what I actually was able to demonstrate with Roger Miller in post-op testing. And these are the areas, the so-called Brodmann areas: brain function, memory, language improvement, and the various aspects of things. And this is a paper that was also published by Dr. Hidani on cognitive enhancement of healthy older adults, so that there's actually, again, objective data substantiating what I experienced, and the cognitive performance was enhanced in those particular areas that you can see on the bottom of the slide. So I'm not going to get into the biological clock. I think Dr. Hidani is going to talk about the effects on aging and telomeres. You'll hear about that, and how it's a measure of aging, and it has significant implications. So these are my telomeres, and I was very impressed when my telomeres were enlarged by 100%. And I thought that meant that I went from 80 to 40 in age. But it wasn't quite the same. But this is, Eric, what was impressive to me when I saw this. I felt better. I'm not sure what it means, but I felt a lot better. And I'll defer this to zombie cells, senescent cells, that Dr. Hidani will also talk about. But these are cells that they're not dead, they're not alive, but when we get older, we have these cells. They spew out inflammatory agents, cytokines, that result in inflammation, which is the common cause of cancer, heart disease, Alzheimer's, and stroke. The inflammation in our bodies, and the diet that Dr. Barzilai talked about and Dr. Verdun are so important. And this is my proteasome, my proteome, showing that at 40 dives, the inflammatory markers in my protein in my blood precipitously dropped as I measured I took blood tests during the period of the dives that I did, confirming again the anti-inflammatory response. And then finally, my cardiorespiratory function was improved, 15% exercise endurance and also my anaerobic threshold. And there have been studies that confirm this. And the other thing that I did a triathlon, swim, bike, run beforehand. I've been competing for the last 30 years, 40 years in this, and I've done 8 Ironman distance triathlons, 5 in Hawaii. You may have heard of the Hawaiian Ironman. And now I'm down to the Tin Man, though. No more Ironman. I'm down to the Tin Man. But I improved my cardiorespiratory function by 9%. And interestingly, my time in the pre and post-op triathlon dropped by the same amount. So that's the finish right down in St. Petersburg last year. And my daughter and I just did this race in August in Chicago. And the one thing that I went to the hyperbaric oxygen chamber for, I was told by Mr. Globig, who is the CEO of Aviv, that it also should help me grow. And unfortunately, it didn't.
Well done. Thank you, Dr. Maroon. You know, Dr. Maroon was one of our clients, and I have a lot of my former clients here. And, you know, one thing, takeaway message is, you know, yes, there are pills that can help. There are different things that can help. And hyperbarics can help. But it takes your effort. And I'll be honest, nobody did it like him. To drop that many minutes off a triathlon time is amazing. So that being said, let's see how he did that. And that's how Dr. Hadani is going to come up and explain our whole program. So please welcome Dr. Hadani.
Good morning, everyone. Thank you for staying. It's really an honor to speak after such amazing speakers. Each one of them is a leader in his field. And you saw Dr. Maroon, really one of the leaders in neurosurgery and apparently also in triathlons. All right, so we're going to talk about the concepts of what we're doing. And when I started studying medicine a couple of decades ago, we were told that we cannot repair the brain. We cannot do the impossible. We cannot regenerate what was lost. However, down the road, science advanced, research advanced, and we know today it is possible. What you see here is a comparison, an amazing work done from the Weizmann Institute in Israel, comparing brain healing to a wound healing. Like a wound in your skin, or in your leg, in your arm. The processes that you see on the left side happening on the skin, and on the right side is happening in the brain. And amazingly, it's basically the same. The cells may have different names, but the concepts are exactly the same. You need the same components to heal your brain as you need to heal any other wound in your body. And when you think about it, that's what we're trying to teach here. We look at the brain and a wound in a brain just like as we look at any other organ. What you see here is a stroke in the brain that a lot of people cannot see. Maybe Dr. Maroon and myself operating patients, we see that. But usually we have the skull and the skin that doesn't allow us to see that. But basically it's the same as any wound that you would see at the rest of your body. And when you think about that and when you change the approach, you want to know, okay, if I'm looking at it just like any other wound, what do I need to heal it? How do I repair a wound in the brain? So we studied this and we found there are 4 main components you need to repair. The first one is energy. And our brain is working mainly, like any other organ, but mainly the brain, on oxygen. We need a lot of oxygen in order to operate. And we know that, for instance, when you're texting and driving, don't text and drive. obviously, that you make mistakes because you're limited in the amount of oxygen that reaches different areas in the brain. That's why you go in and crash the car, because you can't text and drive. Well, maybe the women can. But us, the males, we don't. So the only way to increase oxygen, to increase the level of oxygen in our brain, is through a hyperbaric chamber. If you take a mask of oxygen right now and put it on yourself and breathe oxygen, as you may have seen in TV or in the hospitals, it cannot really increase the level of oxygen in the brain. We are limited in the amount of oxygen we can supply with an oxygen mask. But if you're going to a chamber like you see here, a hyperbaric chamber, we compress the air around us, we increase the pressure, and then we give an oxygen mask. That utilizes an interesting physics law that it enables to dissolve a lot of oxygen in your blood and in your tissues. It's very similar to thinking about the Coca-Cola. Coca-Cola has a lot of gas, CO2, dissolved in the fluid. When you take off the cap, that's the gas running out, because a lot of gas was dissolved. So when you go inside the chamber, basically, we're making you a can of Coca-Cola. And you definitely need energy in order to heal a wound. You need much more energy than the regular activity. So that's the first component. The second component, you need a trigger. The body needs to know we need to heal the wound. The wound is there, but you need the body to go and deal with it, to start working on it. So you need something to tell or signal the body to do that. And we know what that trigger is. Trigger is called HIF-1 alpha, or if you want to sound fancy, hypoxic-induced factor 1 alpha. That is a molecule that was discovered in 1995, and the researchers won a Nobel Prize. And this molecule is being released usually when cells are feeling stress, when there is low level of oxygen. That's the trigger for the body. Okay, I have low level of oxygen, I have to act, I have to do something, I have to repair because I am feeling stress. But we have discovered, using a very special protocol that we do, we are actually able to release that factor without putting you into stress, without giving you low level of oxygen, but the opposite, giving you a lot of oxygen, giving you much more than oxygen than you need, a lot of energy. The reason for that is because the body feels relativeness. So we're giving you a lot of oxygen and then back to normal. A lot of oxygen, back to normal. That difference causes the body to think it's under stress when it's actually not under stress at all. So you are able to release that trigger without the negative stress. We have shown it that the more we do sessions in the hyperbaric chamber, we get more and more of that trigger. That was the second component. The third one is stem cells. I'm sure you've heard of stem cells. Those are the special cells that we have in our body that can divide and mature and become any type of cell and repair ourselves. The problem with aging is we have decreased number of these cells, and they don't function as much as we want. We have shown that with our protocol, we're able to recruit them and have them repair what we need them to. One type of wounds can build blood vessels. The other type of cells can divide and build new brain cells, new nerves, new cardiac cells or heart cells, new liver cells. Again, the more we do the protocol, the number we have hit is 60 sessions, as you heard Dr. Maroon. That's when we have the top or the maximal number of cells do their work. That was the third component. The fourth one is angiogenesis, or new blood vessels. You all understand that if I try to plant a seed, try to grow something in the middle of the desert, it will die. It doesn't have the right infrastructure for it to develop. We need to nurture it, right? We need to supply the nutrients for the plant to grow. However, if I plant the seed in the green fields, as you see on the right side, I'll be able to repair, I'll be able to have that plant grow. So that's exactly the first component. I need to create new blood vessels in that area that I'm trying to repair in order to repair it. And we have shown this. This is in mice, work by other researchers that have shown that if you do the protocol, you are able to create new blood vessels. We have shown it in human beings. This is traumatic brain injuries that you've heard from Dr. Maroon about. You see on the left side, the first row is their MRI scans of their blood flow. That's the first row before we treated them. And then on the second row, right here, is what we found after. And we see increased perfusion, increased blood flow in the traumatic brain injury patients. And the reason for that is because we created new blood vessels, or again, if you want to sound fancy, angiogenesis. So those are the four components. We talked about energy, a trigger, stem cells, and new blood vessels. So now that you learned that, and we know the approach, what can we do with it? This is an example for a stroke patient you have heard about a bit from Dr. Maroon. This is a 62-year-old woman who suffered a stroke about 14 months before she came to us. She suffers from right side weakness, and she couldn't speak, what we call aphasia. We have done our evaluation, which includes the SPECT scan, which evaluates the metabolism, how well is the brain functioning. And we found the reason why she's not able to speak and why she cannot move her hand and leg. We saw low metabolism there. Because we saw those areas, we treated her with our special protocol. And you see on the left side, on the right side, those areas in circle improved their metabolism. Those are the areas that are responsible for speaking and for moving the right side. They improved in the scans, and they improved clinically. The woman began to talk again and move her right side. But what happened to us with aging? With aging, this is how our brain looks like. All those white spots there are tiny strokes that happen to us all the time. I'm going to show you a little movie, if you can hit play for me. Doesn't work? Okay. I'll tell you what was in the movie. Basically, what we have there are patients who have done week-by-week MRIs, and we see that every week we get a tiny stroke happening to all of us every week. We have that happening. The reason is as we age, we have less blood flow to our brain. We have the disease we call atherosclerosis that constricts our blood flow, and we have relative hypoxia or relative low oxygen in our brain, and the brain suffers and have this condition. Because of that, we've started a program to target aging. We're taking patients, individuals over the age of 65, do it even earlier, who were healthy. They did not have any significant comorbidities, and we have evaluated, can we target their cognitive function? Can we target their physical function? Can we compete with the aging process? And we did. We found significant improvement in their cognitive function, in their memory, in their attention, in their processing speed, in their planning, what we call executive function. All their cognitive function significantly increased, significantly improved. All those times that you may think to yourself, I'm forgetting words, I think I'm thinking a bit slower than I did before. Those are the things that we lose with aging, and we were able to change. We saw it correlated with actual changes in the brain. We had significant changes in the brain matter, in how the neurons are built, and the metabolism and perfusion or blood flow in those areas. We've also targeted physical function. As you heard from Dr. Maroon, all our patients have increased physical function. This is a machine that we evaluate everyone for their maximal aerobic performance. And we see that we can increase maximal aerobic performance by 15%. This is why Dr. Maroon was able to perform better. We have correlated this with also increased blood flow to the heart. The heart had regenerated new blood vessels and much better perfusion or much better blood flow in order to supply and in order to withstand such physical workouts. Last thing, we also tested the biomarkers. You heard from our previous speakers a bit about senescent cells. Those are the cells that are the zombie cells, the cells that we have accumulate with age, and they are there and they're just doing bad things apparently. They are the reasons that correlate with Alzheimer's, with cancers, with cardiovascular disease, and a lot of different approaches are trying to take them out. We have found that using our protocol, we are able to decrease the numbers of these senescent cells, like you saw with Dr. Maroon. We've also shown that we are able to increase the telomere lengths. Like you've heard, telomeres have different sides of the coins, but this is a biomarker of aging. We do know that it shortens with age. We've shown that we are able to increase it. We also showed this effect in the skin. Remember the senescent cells that we were able to decrease in the blood? We also did it in the skin. This is biopsies from the patients in the study. We've shown that we decreased the number of senescent cells in the skin, and it translated to better skin quality. We had more elastic fiber. We returned elasticity to the skin. So this is what we do in the clinic here. We are utilizing this medical program that is established scientifically. We start with the assessment. Dr. Maroon told you that what the assessment includes. We do all the assessment, all the cognitive and physical function and biomarkers to all of our patients. And we do this to personalize the treatment that we do. And on top of that protocol that I've told you, we combine it with all the pillars that Dr. Verdin has told you about. We do personalized nutrition, if you remember those 5 pillars. We do personalized aerobic training, like you've heard, and we do personalized cognitive training to maximize the effects you will get. My last slide, I just wanted to tell you that during the last period that our country has faced with with the COVID epidemics, obviously, pandemics, and as you know now, we're facing the long COVID problem. A lot of our workforce and a lot of us suffer from long COVID. We've shown this. It happens also in older age and basically to anyone. The numbers are huge. So we have also studied that, and we have shown we are able to affect long COVID syndrome. We are able to decrease the symptoms, to decrease energy, and improve the cognitive function, that brain fog a lot of people are actually talking about. So if I summarize, I wanted to show you today that brain repair and regeneration is possible. We're also able to repair the physical function, the biomarkers of aging, because we target the basic components of healing and repair. However, you do need a proper evaluation protocol and a proper protocol to have that. Thank you very much.
All right, how was that? Very good, excellent. All right. So, you want to go home, or do you want them all to come up for a Q&A? Okay, Q&A, all right. So please have me welcome back Dr. Hadani, Dr. Maroon, Dr. Barzilai, and Dr. Verdine. So what we're going to do is we're going to start with some general questions that I anticipated you were all going to ask, and we'll kind of get through that. And if you still have questions, then we'll kind of call people out in the audience. So the first question is maybe a little bit personal. And I saw a lot of people wanting to ask a question about calorie restriction, Dr. Verdine. So maybe explain a little bit more about calorie restriction, and maybe what do you do? And then I'm going to eventually ask, how do you all eat?
Cool. So calorie restriction, I think there are some humans who are on calorie restriction, and I've met them. They had actually one of their meetings at the Buck Institute, and the summary of that group of people is that it might not make you live forever, but it will certainly feel that way.
By the way, they were going to meet me a few months later, but they never showed up. I think they died.
So calorie restriction is not the way to go. What's interesting, the data that has come out of this is you can gain many of the same benefits by fasting. And if you think about, I'll just say a word about what fasting means. We have two different ways of metabolism. One is when food comes in, we're using that food as a form of energy. So you eat, you digest, that food goes and utilize it with oxygen to burn and to create energy. When we don't eat, we're relying on energy that's inside, and mostly fat. So we shift and we start burning fat. So during the fasting period, the metabolism switches to burning mostly fat. Either fat from our fat tissue, but also fat and other proteins from our cells. And there's something amazing that happens, a process called autophagy, which means self-eating. When you are fasting, your body goes into every one of these your cells and starts cleaning up. It mops up, and it eats itself to generate energy. But it does this in a beautiful way because it eats mostly what is dysfunctional. So it looks at your organelles, your mitochondria, and all this that are not working well, and it eats them. So that being said, fasting is really important. And so one of the things that many of us do in our daily life is to maximize the amount of fasting that you spend every day. And there's something called time-restricted feeding, which is the idea that you limit the amount of hours that you eat in a day to 8 hours. Turns out most of us eat for 16 hours during the day. So we get up at 7 in the morning, we eat until 11. So if you actually switch this around to restricting your feeding window to 8 hours, a lot of people see beneficial effects. I certainly do this. I know Nir does it. Many of us do this. It's probably the easiest thing to do. Another way to do this would be to do every 3 months, sort of a 1 week fasting. You'll hear about many fasting protocols. They all reach the same principle, but I find it to do on a daily basis is probably easier.
But I want to tell you my experience of the caloric. By the way, my labs are doing caloric restriction for 30 years, okay, in mice and in rats. And we all get this control group that's caloric restriction. So every drug that we'll try, we have a positive control. And people took it to say less for breakfast, less for dinner, less for lunch, for dinner. But in fact, we are giving the food to the animals in the morning. They're hungry, so they eat it in 20 minutes. And then they are 23-hour fasting. Okay? That's why I'm doing caloric restriction, because when we give the same food to the animals during the day, they don't live much longer. They are thin, but they don't live much longer. So the fasting is really important. That's why I'm doing the same. And by the way, we're both performing best under fasting, you see. You know, if you ask us, and we'll be fasting until 1, 2 today, but it's really easy and it's really good.
I will acknowledge this because last night they had a smaller group with some physicians and they did a similar presentation, and they have a lot more energy this morning than they did last night. So
By the way, one thing also, you can exercise while fasting. I go for a 3 or 4 hour bike ride fasting. Never had, I mean, it takes, so one thing that let's say you want to know, how do I do this time-restricted feeding? most of us do it in a way that I start eating, and I know Nir does exactly the same thing, between 12 and 1, and then I eat until 8 or 9 p.m., and then that's it. And in between, nothing. And that you can drink black coffee or tea, but no sugar, no milk. Anything that has a calorie should not be in your mouth. Now, the best way to do this would probably be breakfast, lunch, and a very light early dinner. But it turns out that socially, and we go back to what I was telling you about, how do you mitigate your social life? You know, if you're on a really strict diet, you can't eat after 4. That means you can never go to dinner with anybody. That's not good either. So I would say the ideal diet would be a big breakfast, solid lunch, and a very early dinner. But practically, especially for someone who's working, I mean, I have a lot of business dinners, I find it easier just to skip breakfast. And now the other thing is, let's say you realize, the first step would be to look at what is your cycle now. Make a diary to try to see, when do I eat? What is my window? For most people, it's 16, 15 hours of eating, 8 hours of fasting, essentially fasting when you're sleeping. And don't go from 16:8 to 8:16. It's kind of hard, but shift it by 1 hour a week for a couple of months and see how it changes.
That's excellent. And maybe that was shifted to, what are some simple things anybody 55 plus can do, whether it's diet, exercise, sleep, interaction? What would you recommend to just, we all know prevention is the best medicine, but today is the first day of prevention. What can I do today?
55 is him, we're older.
Yes.
I basically have utilized the Mediterranean diet for most of my time, but I think these two gentlemen have convinced me tomorrow I'm changing. The other point I would like to make that Eric pointed out, when you fast, in our ancient days, it was feast and famine. And when you feast, you build up fat, and when you have a famine or shortage of food, you burn up the fat. But in burning up the fat, you're releasing energy molecules called ketone bodies. And you've heard of the ketogenic diet. And I mention that only because I've worked with Thomas Seyfried, who's an investigator at Boston College, who has written many papers, and I a few with him, on the metabolic approach to cancer. And as we know, cancer is completely dependent on glucose, sugar, for its metabolism and growth. So that the hypothesis is that if you can starve the cancer of sugar, and the body can live on ketones, which is what you burn when you burn up your fat, it has a therapeutic effect. So that in the treatment of cancer, the ketogenic diet, in addition to chemotherapy or radiation therapy or traditional therapies, clearly may have some benefit in terms of prolonged longevity.
So we heard a little bit about metformin. I think one question was, is there a specific dose of metformin? And then maybe what are some new things in addition to metformin? You heard about ketones, how about ketone esters, and there's some other supplements you can take. A lot of people ask about supplements, and I always tell people supplements are to supplement a good diet. But then they still ask me, okay, but what can I buy and take? So is there anything on the horizon in addition to metformin?
So I'll answer you metformin, and you'll do the rest. So, by the way, I'm not trying to sell you metformin, okay? I'm doing a study. I don't want anybody to ruin this study. And the study, I want to just clarify one thing. Metformin has proven to do what we said it's going to do in individual studies, okay? We're just packaging it differently because of the FDA, okay? So it's always a challenge for me to think, do I tell people to take metformin? Because I can I can rebrand anything. I can, as a physician, I repurpose any drug, but I'm not pushing for that because I don't want it to be before the FDA approves that. But if you're asking, the dose we're going to use for the TAME study is 1,500 milligrams in an extended release form. Now, there are 3 to 6% of people who wouldn't tolerate metformin. And some of the intolerance is because they don't have the mechanism that takes metformin into the cell. So never mind, you know, don't push it. But most people will not know that they're on any drug, except that they might be losing weight and you know, some other benefits that I don't want to tell you, so that you'll tell me what you feel. But that's the dose.
Okay. Any warning signs that somebody should start looking out to say, hey, I need to ask my doctor about this? Any subtle signs that, you know, people should be looking out for now? And that goes across the board, whether it's neurological, physical, cognitive. And that's for everybody here. Amir, if you want to start.
Yeah, sure. So just going back one question before, you asked what people can do today, and I think Dr. Verdin touched this. So I think nutrition and exercise is something that everybody should do. Everybody should really take care. I know in the villages it's a big thing, and it's great. But definitely think about it every single day. Are you doing what you want to do, or are you limiting yourself? So definitely nutrition and exercise, and you don't have to be a triathlete to do exercise. You can do it much easier, like 25 minutes a day of walking, easy walking. Definitely should be done. And intermittent fasting or any other diet, there are different types. I'm doing intermittent fasting as well. You want to say something? So warning signs, so definitely there are a couple of warning signs that if something changes acutely, if you do feel that something has changed in a very rapid event, something has changed significantly in the past couple of days, couple of weeks, this is something you should definitely go and look for medical assistance or talk to your PCP. Things like significant cognitive decline, you're starting to forget critical things like leaving something on the stove or forgetting where the keys, not like when you were on the phone and doing 5 different things, but if you just basically have no idea where you put things that really deteriorated. Yes, those are times that you should go and check if something happened, because it's rare. I would say that the rare causes are rare. Mostly it's part of aging to have something happen and to feel those memory loss or forgetfulness. But there are the rare cases. There are some things like you fell down a couple weeks ago and there may be a small bleed in the brain that causes that. So definitely if something changes rapidly and you feel it's more of the abnormal, yes, you should treat it as a warning sign.
Just a quick,
Go ahead.
Just a quick observation. I know there are 33 states now or so that have legalized marijuana, and I know that doesn't apply to anybody in this room. However, we have what's called the endocannabinoid system, like the respiratory system, the GI system, endocannabinoid system, which are receptors in our brain. And when Amir mentioned taking a walk or working out or any kind of exercise, what you're really doing is stimulating your own endogenous receptors so you can act like you're having a little poke of THC or something when you go for a walk, because that's the same feeling you can get from exercise. So another incentive to do it.
Another way that I would encourage you to think about your own health is, rather than wait for something to happen, think about your health as a bank account, an investment account, and in which you have 4 buckets. And these buckets are the ones that I mentioned. What I try to do is every day I put something in one of each buckets. And so, you know, one day, if you don't want to fast every day, fast one day a week. And just experiment with all of these changes. If you don't walk at least one day a week. And you will see that the most amazing thing is that small changes make a big difference very quickly. And so what I have found, at least in terms of my personal journey, is that the more I put in each of these buckets, the more I want to put in, because I realize I sleep better, I exercise stronger, I think better. So it is really, it's actually a profoundly amazing what your body at any age can do. And so the idea also is that in many of the interventions that we do in the laboratory setting, we find that in animals, no matter what their age is, interventions still work. So there's never a point where you can say, well, it's too late. And so to me, this sort of proactive vision of health as something that you work at is really something that I hope we will be able to, to convince people to invest in.
Or I can give you an address of dispensary in Massachusetts, and they'll send you marijuana in any form you want. It's always.
One last word about supplements also, because I'm the same. We all want something magical that we will take that will make everything go away without any effort. You're all old enough to know that this doesn't happen. Everything that's worth it has a price and takes work. But so there's a whole industry of supplements that are touting, this and that. And I do take some of these supplements, although I don't like to advertise which one I take. But the thing to realize is that none of the supplements are proven. That's why they're called supplements. So when you are buying them, it's an act of trust. When you're buying a drug, it's been vetted by the FDA, it's been proven to work, at least in the majority of people. When you're buying a supplement, it's an act of faith. So you can base this faith on what you've read in the papers or some scientists that you trust and so on, but it's not proven. That's number one factor. Second factor is there are many unscrupulous vendors. So most of the supplements that you buy don't contain what they are saying is in the bottle. That's 70% do not contain what's written on the bottle. There is no regulation. So the FDA, nobody is controlling what's in those pills. And I've heard of some horror stories. So if you're buying supplements, buy from reputable sources. That's the first thing. And I'm not going to be in the business of advertising which ones to look for, but you can search it on the internet. There are a few companies that are well respected and highly regarded, so you can buy things from them. But for the rest, I would say just be cautious.
But one thing is proven on supplement. They're good for the economy.
Yes. Yes.
That's very true. So I think I'm going to be brave and open it up to you guys. So what I'm going to do is I'm going to call you, and I'll repeat your question so that way everybody on the camera can hear. So front row always gets respect because they came early. Yes, ma'am.
I just wanted to clarify what I heard about the metformin dose. For non-diabetics, it's 1,500 milligrams extended release once a day for diabetics or non-diabetics.
Correct.
So she was just clarifying the dose, 1,500 milligrams extended release of metformin for diabetic or non-diabetic.
Metformin will not lower your glucose. It'll lower your insulin, but it's not going to lower your glucose.
Once a day, extended release.
If the extended release.
Right. Yes, sir.
Do you think Prevagen works?
Do you think Prevagen works, the jellyfish? I'll open it up to any of you guys. I think their smiles say the answer. But I'm going to say no. It doesn't.
We didn't take it, so we don't think.
It's not an approved drug.
No.
Yes.
So, I know.
Listen, for us, for something to prove, even if it's a supplement, you need a clinical study. Okay, you need to take people. Some of them will take the drug, some of them will take the placebo. And if I don't have this data, I cannot tell you anything. I want to tell you an example of something really amazing. You know Mars, the candy bar, Mars? They did a study and published it. It's called Cosmos. They took 20,000 people and gave them either a cocoa powder or a placebo. Tastes good, but no, it wasn't the cocoa. And they actually decreased cardiovascular disease by like almost 30% and also overall mortality. Okay? It's still a supplement. The FDA doesn't allow them to write on the candy bar what it is, which is a thing that we're trying now to approach. The FDA, we want actually to know if supplements are being tested, they should have something like that. But I'm giving you an example, but if you don't have this example we are not going to tell you anything, even if the anecdotes are amazing.
And I want to add something because that's an important point. There are supplements or medical foods that can actually make claims. For example, some of you might be eating Quaker oats. It says on the Quaker oats it will lower your cholesterol. It's true. And the reason they can make that claim on the box is that it's been proven in a study. The same thing for the cocoa powder. It contains what we call flavonoids. And they've not only shown decrease in cardiovascular disease, but also increase in memory. And this is a clinical trial. So you can buy the supplement, and it will say improves, increases your memory. So if you see a supplement that makes a claim on the bottle, most likely it is true. Yes.
We're all going to go buy Mars candy bars now, right?
It's actually not the bar. It's
not the bar.
It's the cocoa powder.
That's right. Yes, ma'am.
You presented a lot of great data on the hyperbaric therapy, and I just wonder where that's going to be in an approval process. Because I can't imagine insurance is going to be covered.
So the most common question about our program is, does insurance cover it, and how is the process going to be for approval for hyperbarics with what we do? Dr. Handani, I'll give it to you.
That's a great question, and definitely it's one of the big issues that we are doing the clinical trials. However, it takes time to get it approved. So we are in the process of it, but it will take a lot of years to get that. To get something approved, you can ask Dr. Barzilai here how long he started with metformin for aging. We're talking about almost a decade now of doing this. So definitely, we are doing the clinical trials. We are at that event, but it will take a lot of time.
The important thing to understand is that hyperbaric oxygen therapy is approved for 13 or 14 different disease processes. Non-healing diabetic ulcer wounds, for instance. Non-healing fractures, actually abscesses of the brain. So the FDA will pay for wounds of the extremities, but not of the brain.
I do want to highlight a point. What was the statistic? How much of your money on healthcare goes to the final years of your life?
50%.
Half, 50%. So I rather pay for a hyperbaric treatment and get better and prevent issues than give it to the ICU team, for keeping me on a ventilator, for example. This person has been very patient with his hand up, so I'll give it to him. Yes, sir.
55 years ago, I was teaching at the University of Wisconsin at the medical school. And I happened to take a semester-long course in the physiology of aging, physiology and pathology. I want to see what was written there. This is the first textbook in this field.
So we are blessed with a pioneer in aging. He has a book from 55 years ago that literally I can see. It says Physiology and Pathology of Aging, and Dr. Barzilai is going to take it from you.
He wants to see if he's in it.
I thought when I started there was 0 pages, so I'm curious. I'll give you back. There's thyroidectomy as a treatment.
Clearly, since humans have been alive, we've been thinking about our age, right? But yes, I'm sure you had a question as well.
My question is this. I used to also teach biochemistry, specifically lipids. And I was very much concerned about the crossover of cholesterol metabolism and the aging process. So I'd like everybody to give me their thoughts about cholesterol metabolism and the aging process.
Okay, so he used to teach biochemistry and specifically about lipids. So he wants everybody to comment on the metabolism of lipids and cholesterol and how it relates to aging. Dr.
Yeah, can you hear me? Yes.
Shall I open the chapter here and you read it?
It's a big question, the one that you're addressing. There are 2 ways to answer. First is when we think about the different forms of fuels that you can eat. There's carbohydrates, there's lipids or fats, and then there's proteins. And then last is ketone bodies that we make during fasting. They burn with different efficiencies, and I compare this to like diesel versus the highest octane gas, for those of you who are mechanically inclined. So think about the cleanest energy that you can burn is ketone bodies, and that's in terms of the amount of toxin that they generate. Second cleanest is fat, and third, protein, and the worst is actually carbohydrates. And so a lot of what many of us do, and actually it turns out that many of the pathways that really regulate aging are dealing with carbohydrate metabolism, insulin signaling pathway. Everybody knows about insulin, so that's the hormone that we use to digest and to store carbohydrates. That's the major aging pathway. So many of us in the field try to, and metformin is an anti-diabetic drug, so many of us in the field, when we think about our aging, we try to mitigate the amount of carbohydrate that we eat. We all need carbohydrate, but healthy fat is the better way to go. Now, there's an extreme of this, which is Dr. Atkins' ketogenic diet, which so we did a study on the ketogenic diet, and mice actually increase their lifespan when put on a ketogenic diet. The only thing they were eating is Crisco as a fat, which sounds terrible. And these mice lived longer than the other mice. So the problem of the Atkins diet is that Dr. Atkins eliminated carbohydrate, but substituted it for highly saturated animal fats. And there's now a new movement that shifts ketogenic diet where you're actually using healthy fat. So I hope this is answering your question. It's quite complicated. Cholesterol gets all mixed in there. It turns out that many of the highly saturated diets are very rich in cholesterol and cause problems on their own. So it's a really complicated question to answer. But the one thing I would like for you to leave with is when you think about carbohydrates, it's like everything in moderation. And
I want to just add something interesting. You know, nutrition is kind of a field that started, people got together and said, let's make some rules. Rule number 1, 3 meals a day. Well, breakfast is a Kellogg invention, okay? In evolution, men would wake up in the morning, chase the deer, get it at night, and have barbecue, okay? Marie Antoinette came much later in human evolution with her cakes, okay? And Kellogg's. And then, not only that, but there start to be an obesity epidemic. And so then what you hear from nutritionists change every time. Now, from an aging perspective, high carbohydrate and lots of protein, which activate this store that is not good, seems not to be good for aging. And there's a shift now. Once it was all about not eating fat. Now, actually, fat is recommended as the major, from an energetic perspective, as the major source. Why are they doing it? Because they know that you all take Lipitor. So they can protect your cholesterol level, but not change the environment otherwise. But if we're doing the right thing, it's totally out there. We don't know.
I think that's the biggest takeaway is, we don't know exactly. So moderation in the end is going to be your best.
And if you're going to eat carbohydrate, is slow-acting carbohydrates. Because that's really one of the big driver of aging is the spikes in glucose and blood sugar that you get. So if you're eating raw sugar, the way we add sugar to everything, if you can eat carbohydrate, but they should be in the form of vegetables or fruits, and preferably the fruits that have low carbohydrates access, all the berries, for example. Now, one thing I'll just give you another thing that I think should not be part of your menu is fruit juice. Fruit juice is essentially, you might as well, eat 2 spoons of sugar. Many fruit juice are the same as soda. They're full of sugar. And so the worst, for example, think about your breakfast. If you're starting with a bowl of cereal and a glass of orange juice, thinking you're doing yourself well, this is not, by our standard, this is the last thing I would ever eat in the morning. And so if you're going to eat carbohydrates, they should be slow, whole wheat bread, whole wheat pasta, the things that are, and you need them, by the way, to live. Most of us should have about 40% of our calories as a form of carbohydrates. I hope that's helpful.
We have somebody with a microphone. That's how smart she was. She took a microphone of her own to ask the question. I can always repeat the question if the can't
That's
hear.
quite all right. Thanks, Mo. Look, I don't mean to add a red herring to the discussion, but what I didn't hear much about and would love to hear more about is the correlation between what you're doing that's improving the brain physiologically and what's actually happening psychologically. There's a resurgence now in research on psychedelics, and so LSD and the MDMA and all of these things which were demonized back in the 70s, thanks to Dr. O'Leary, or Doc Leary, whatever he was, is now coming back into the fore. So that's a two-part question in the sense of your opinion, your professional opinion on what exactly the impact of that might be going forward, but more importantly in this context, the impact of any of that research on an aging brain.
You want to repeat it? Or?
So the question was on psychedelics and some of these medications and classified as drugs in the past that are having a lot more research. Is there any impact on them right now with the brain and aging?
So I guess for the first part, definitely we are using different methods to evaluate the psychological effects, and definitely we see improvement. Well, the holy grail of aging psychology would be quality of life, and we have those measures and see improvement in quality of life. However, we also evaluate the different, pathological measures such as depression, anxiety, and different measures like this. And we also are able to see improvement in those measures. The problem with evaluation of the psychology, as you know, is it's mainly subjective. We don't have an objective tool to say, okay, this is a depression or not. There are different studies that are trying to do it with blood samples and such, but it all comes down to the patient report on different questionnaires or different interviews. And that kind of limits our ability to evaluate things. As for the second question, so definitely there is an upsurge on psychedelics. I would say the one leading is MDMA. A lot of different groups are investigating it for PTSD and other pathologies, and it looks good. It looks good. They're doing great clinical trials, and we are able to see that kind of format enables patients who has these kind of pathologies to reorganize the brain. However, I would say that we are also studying the combination with our protocol and see if we get synergism with this. It's definitely on the roadmap.
Just maybe jump into, there is incredible data that indicates that optimism, happiness are strong predictors of a long life. And in some ways, the problem is that it's very hard to model this in animal models. How do you decide whether your mouse is happy or unhappy? So there's a lag in terms of the research of trying to understand, how do these processes, everything we do in the model animals is to accelerate the work, obviously. When we go to humans, it's much more complicated, we're much more varied and so on. Obviously, this is what we want to understand, but the data is there that a positive outlook on life, a positive vision of what your own aging would look like, all of these are strong predictors of how long you're going to live. And this is why I always talk about these buckets. Just the simple fact of investing is going to give you a more positive sense in terms of what you're doing for yourself, and this by itself will become predictive. So, it's the devil you know, the devil you don't know. Some people tell me, I don't want to know about this, and I don't want to think about this. I think, you don't think about this, but your body does think about it every single day. So there is a great need for more research in this whole area. We know, for example, now there are studies coming out on loneliness, which is, by the way, is worse than any forms of cancer. So the people who score the lowest in terms of their loneliness in terms of life expectancy is really something really bad for your health. So we are social animals. There's no question about it. Look at all of us in this room enjoying a conversation. We love social relationships, social connection. So I hope this answers the question.
That was excellent, and it actually wraps it up perfectly. Unfortunately, we won't have any more time for questions. If you do have a question, though, if you email this address, info@aviv-clinics.com, you can even specify who you want the answer from, and I'll be sure to get you those answers. If you're interested in future seminars like this, if you just go to our website, aviv-clinics.com, or call our number, we'll be able to give you those facts. I think that final statement was probably the best. You guys are all here today to learn. You're all here together. We've all been through a pandemic for 3 years. So positive outlook. You're all amazing, smart, beautiful people, so give yourself a clap, and please welcome. And Dr. Barzilai had to run out to his taxi to catch his flight. I'm glad he returned the book, but we'll say he did a great job as well. Thank you.